This is the first of two videos on writing chemical equations. In this first one, we're going to focus on balancing chemical equations. This will be on all tiers of the exam, both foundation and higher. And the aim is to make sure that you have the same number of atoms on each side of the equation. It's important that you never change the formula that you're given, because it will be the correct one. Leave oxygen to last, as it is the most complex. And normally, if you've balanced everything else, then oxygen will fall into place. So let's do some examples. So this first one, we've got copper oxide and hydrochloric acid going to copper chloride and water. Now what I tend to do, I draw out the atoms of the elements, so copper and oxygen, hydrogen and chloride, copper and two chlorines, two hydrogens and an oxygen. Now, when I've got this, makes my balancing much easier. So, let's start. So, I've got one copper here, and I have one copper here. So they're okay. Leave the oxygens to last. I've got one hydrogen here, and I've got two hydrogens here. So, what I like to do then, you draw another hydrogen chloride molecule. We've now got two hydrogens on each side, so we're happy. Chlorines, we've got 1, 2, and we've got 1, 2 there, so they're happy. Now let's go back to the oxygens, one oxygen, so they're happy. So in terms of the balanced equation now, please, what we've got one copper oxide, we've got 1, 2 hydrochloric acid, so we've put a big 2 in front. We've got one molecule of copper chloride and we've got one molecule of water. So that is a balanced equation for that reaction. Now, next one, we've got methane reacting with oxygen to form carbon dioxide and water. So again, let's draw out what we've got. One hydrogen, one carbon, 4 hydrogens. And we've got 2 oxygens. We've got 1 carbon, 2 oxygens. 2 hydrogens, and 1 oxygen. Now, let's start our balancing. We've got 1 carbon, 1 carbon. So they're balanced. 4 hydrogens. Now we've only got 2 hydrogens here, so we need another 2 hydrogens. So that means we need another water molecule. So 2, 4, they're happy. Now then, let's look at our oxygens. We've got 1, 2 on the left-hand side, 1, 2, 3, 4 on the right-hand side. So we will need another oxygen molecule. Now, the balanced equation for this will be, we've got 1 molecule of methane, we've got 1, 2 molecules of oxygen, forming 1 molecule of carbon dioxide and 2 molecules of water. So we have a 2 in front. Now, I don't expect you to draw these out all the time. Some of you will be able to do this in your head and we'll be able to shortcut the process. But I intend to do that through the examples to show what we can do. Now, next one. Sodium hydroxide reacting with zinc sulfate to form sodium sulfate and zinc hydroxide. Now, So sodium, Na, oxygen, hydrogen. Zinc sulfate, we've got zinc. S for sulfur, and because it's O4, it's 4 oxygens. Sodium sulfate, we've got 2 sodiums because it's Na2. We've got 1 sulfur, and again, we've got 4 oxygens. We've got zinc hydroxide, zinc. Now, because it's bracketed, that doubles everything inside. So, oxygen, hydrogen, then oxygen, hydrogen again. Now then, let's do our balancing. We've got 1 sodium, and we've got 2 sodiums here. So we will need another sodium hydroxide. NaOH. So now they're happy. Hydrogens, we've got 1, 2 on the left hand side and 1, 2 on the right hand side. So they're happy. Remember, we're leaving oxygens to last. Zincs, we've got 1 zinc, 1 zinc. They're happy. Sulfurs, 1 sulfur, 1 sulfur. So they're happy. Now, in terms of oxygens, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're happy with the oxygens as well. So the balanced one will be, we have 2 lots of sodium hydroxide, 1 molecule of zinc sulfate, 1 molecule of sodium sulfate, and 1 molecule of zinc hydroxide. As you can see, everything is balanced now. You'll notice these are getting slightly harder as we go along. Now the last one I want to balance is this, is copper carbonate. So copper, Cu, carbon, and 3 oxygens. Nitric acid, H, N, and 3 oxygens. We've got copper, Cu. Now, don't forget, this doubles everything inside the bracket. So 2 nitrogens, 6 oxygens, carbon dioxide, we've got 1 carbon and we've got 2 oxygens. And in water, we've got 2 hydrogens and 1 oxygen. Now you can see from this example why I say leave oxygens to last. So let's do some balancing. 1 copper, 1 copper, so they're fine. 1 carbon, so they're fine. 1 hydrogen, 2 hydrogens. So we've got 1 hydrogen on the left hand side, so we need another molecule of nitric acid. So now your hydrogens are happy. We've got 2 nitrogens there, we've got 2 nitrogens there, so they're very happy. Now let's count our oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in terms of the balanced equation for this, we've got 1 copper carbonate, 2 lots of nitric acid, so it's 2HNO3, 1 molecule of copper nitrate, 1 of carbon dioxide, and 1 of water. Now this is a prime example of where we leave the oxygen to last, and if we balance everything else, the oxygens fall in place.